quiet November sky, and a traveller from another star passing between Mars and the Sun, leaving behind less than it should, more than we can explain. You've arrived here for a reason, observer, as if the cosmos nudged you toward a question it refuses to answer. What are the odds that an object could brush through perihelion, yet lose no tail at all, a 1 in 20,000 orbit? A silent acceleration, a fragment of another star drifting unchanged through fire. Some mysteries speak loudly by saying nothing. This is one of them. Stay a while, traveller. Imagine this. A quiet sky, a drifting visitor, and the soft realization that something we expected to see simply never appeared. Tonight, traveller, you and I step gently into that silence, into the question of what it means when the universe refuses to behave the way our equations assure us it should. For months, astronomers, observers, and quiet late-night watchers across the world waited for a single moment, the return of Threadset Atlas, after its close passage around the Sun. Perihelion, the place where fire meets ice, where ancient bodies shed their secrets, in brilliant tales of dust and light. It is a ritual as old as comets themselves, a ritual written into the physics of sublimation, pressure, radiation, momentum, a ritual that every comet must obey. But when the first images arrived on November 5th, something was missing. What we saw was simple, almost serene. A compact glow, soft around the edges, unchanged in shape from the images taken months earlier. No dramatic plume, no sweeping tail, no sign of the violent shedding that physics tells us must occur when a comet rounds the Sun. It was as though 3i Atlas had passed through fire without burning. And so, traveller, the question formed, not in urgency, but in wonder. How can an object accelerate strongly measurably without leaving behind the evidence of that acceleration? Astronomy at its heart is an act of listening to light, to motion, to silence. And 3i Atlas offered us a silence so deep it echoed. The observatories that captured these first images were not casual participants. They were seasoned, meticulous instruments of the night, the Arneves Observatory in Spain, the Virtual Telescope Project teams of astrophotographers who have spent decades decoding the faint language of comets. Their images aligned with the same quiet message. A coma was present, faint round familiar. But the tail, the expected traveller's trail of gas and dust, it simply wasn't there. To understand the significance of this absence, we step back into the certainty of physics. When a comet accelerates through non-gravitational forces, that acceleration must come from something leaving its surface gas, dust. Frozen molecules turn to jets of vapour. And the Jet Propulsion Laboratory, with data available for anyone to examine, confirmed that 3i Atlas experienced a non-gravitational acceleration strong enough to be statistically undeniable. A 3.7 sigma signal, not noise, not a glitch, a push. The numbers unfold like a whisper of mathematics. A radial acceleration of 1.1 x 10^6 UU day 2. A transverse acceleration of 3.7 x 10^7 AU day 2. These values, abstract as they may seem, translate to something profoundly physical. The object should have lost at least 13% of its mass during perihelion. 13% not a poetic metaphor, but a literal measure of what must have been expelled for the laws of momentum to hold. If Atlas were a 5-kilometre nucleus, that would mean billions of tons of material blown into the void, a mountain's worth, an entire continent of dust made momentarily airborne, and yet the skies are quiet. The telescopes show no trace of such an event. The coma is still small, the tail is still non-existent, the fire, it seems, left no ash. This contradiction is not a flaw in the instruments nor a gap in the observer's experience. It is a quiet but persistent invitation to humility, a reminder that we understand only a small piece of the universe's vocabulary. Astronomers did what scientists always do when confronted with the unexpected. They compared, they calibrated. On November 3rd, just 2 days before the mysterious images of Atlas, the same observatory captured another comet, Comet Lemon. And Lemon behaved exactly as a comet should, a bright tail sweeping outward from the Sun, a visible plume of outgassing, a signature as old and familiar as cosmic dust itself. So why does Comet Lemon, modest and unremarkable, display the traditional shape of cometary life, while Atlas, with its required mass loss far exceeding Lemon's, remains strangely symmetrical? Why does the smaller, gentler object sing the comet's usual song, while the louder, more violent one stays silent? Silence is the cosmos's first language. But even silence has patterns. Could the gas be there but invisible, perhaps too faint or too diffuse? That idea was tested too. Months earlier, instrumentation from Spherex and the James Webb Space Telescope detected carbon dioxide near 3I Atlas, when it was far colder and much less active. If a small, delicate plume could be seen from such a distance, then the enormous outburst required at perihelion would be unmistakable now, and yet it remains unseen. The timeline only deepens the quiet mystery. For months, July through September, Atlas followed a purely gravitational path. More than 4,000 measurements from hundreds of observatories confirm a simple truth: it behaved like an inert traveller, drifting without exertion. No push, no deviations, no hidden energies. Then October arrived. As Atlas approached perihelion, something changed. ALMA detected that the object was not where it should have been. A deviation appeared, a shift, a push that gravity alone could not explain. And this timing aligns curiously with the moment solar heating should have peaked the exact moment in the natural model, when outgassing should have been at its maximum. The timing fits the comet we expect, the aftermath does not. If perihelion unleashed a storm of sublimation, that storm should linger in the form of a tail, a quiet arc of dust stretching behind the traveller, catching sunlight as it drifts away from the sun. But instead of a storm, we find stillness. Instead of evidence, we find absence. A silence deeper than prediction. This contradiction, acceleration without tail heat, without plume motion, without debris, sits at the heart of the mystery. Not as a crisis, but as an invitation. Not as a threat, but as a gentle reminder that even with our telescopes, our equations, our carefully written models, the cosmos remains larger than our certainty. And so we return to the beginning, to the question hidden between the lines, to the quiet revelation that 3I Atlas, whatever it is, refuses to play the role we assigned to it. Perhaps traveller. The truth is not something we will solve tonight. Perhaps the universe is telling us something subtler, that not all patterns must repeat, and not all wanderers behave as their predecessors did. Some follow ancient rules, some write their own. And as we watch this silent traveller move through the inner solar system, we're reminded that wonder is not born from answers, but from the luminous space where answers have not yet formed. It's all right to not understand. Tonight the stars will keep their silence. Imagine this observer, a single spectrum of light gathered from a distant object arriving like a faint memory carried across the void. In that thin band of colour lies the quiet truth of what 3I Atlas is made of, not through images or silhouettes, but through the language of atoms themselves. Light reveals what shape cannot, and chemistry whispered through photons can sometimes say more than any telescope image ever could. In August, before the sun drew near enough to test the nature of this interstellar traveller, the Very Large Telescope in Chile turned its instruments toward Atlas and listened. What it found was not loud, not dramatic, but deeply peculiar, a signature of nickel glowing in the coma. Nickel alone, strong and unmistakable, and beside it, the element that should have accompanied it across cosmic history was quiet. Iron, the old companion of nickel, was barely there at all. To a casual listener, this might seem like a small detail, a footnote in a vast story. But to astronomers and chemists, it is the beginning of a longer meditation, a soft, persistent question about the way matter is forged in the universe. Nickel and iron, born together in the cores of dying stars, travel through galaxies in nearly fixed proportions, 20 atoms of iron for each one of nickel. It is one of the universe's quiet constants, a ratio so stable we use it as a reference point for natural formation. But 3I Atlas does not follow this rule. Its nickel to iron ratio is not slightly different, but drastically so, a greater than 3 sigma outlier, A deviation so large it stands apart from every known comet, asteroid or icy fragment that our telescopes have studied. Even 2I Borisov, another traveller from another star, displayed a perfectly ordinary ratio as expected from natural cosmic chemistry. So why, traveller, does 3I Atlas glow with Nickel's voice while iron remains nearly silent? Tonight the universe whispers again. There is a molecule on Earth, rare, volatile and striking, called nickel tetracarbonyl. It does not exist naturally in the cold openness of space. It forms only under controlled conditions when carbon monoxide binds to nickel in a precise engineered structure. On our world, it appears only in laboratories and industrial refining processes, only where intention exists, and yet the spectral lines recorded by the VLT can be fully explained by this very molecule, a fragile compound, a purposeful one that evaporates easily, that breaks apart under sunlight into nickel atoms and carbon monoxide, exactly what the telescope saw. Scientists grounded in humility did not leap to conclusions. They asked instead whether exotic environments might exist where such a molecule could form naturally. Some proposed that unusual protoplanetary disks might produce such conditions. Others wondered if interstellar radiation could sculpt chemical pathways never seen in our solar system. Each idea was offered carefully with respect for the unknown. And yet each explanation requires conditions we have never observed. It is not that the artificial interpretation is preferred, only that the natural one demands a kind of astrophysical imagination that reaches far beyond our existing models. The coma tells another quiet story. The James Webb Space Telescope detected a composition of mostly carbon dioxide, nearly 87%, with a remainder of carbon monoxide and only a small whisper of water. This is unusual but not impossible. It paints Atlas as an object born in deep cold far from a star's warmth, an object shaped in a place where water freezes so solidly that carbon dioxide dominates the volatile inventory. But here the puzzle deepens. Nickel, a metal that forms in the violent heat of stellar furnaces, appears alongside this deep cold signature. Two histories in one body, the cold of distant formation and the heat of processed metal coexisting without explanation. It is as though 3I Atlas carries two origins in the same shell. Somewhere beyond our reach, something ancient still moves. A geophysicist studying the object offered a different interpretation, quiet, patient, simple. He suggested that Atlas may not be a pile of loose ice and dust at all, but something more solid. A body rich in metal and carbon, capable of withstanding the sun's heat without shedding mass the way a fragile comet would. If true, this would explain the missing tail, the muted brightening, the unexpected resilience. A solid object does not behave like a dust-bound iceberg. It does not crumble, it does not erupt. It simply passes through sunlight and continues on its way. But if it is solid, then what is the source of the nickel gas? What surface process would allow such a metal to evaporate gently into space at such low temperatures? No natural pathway is obvious. And so, the questions pile softly atop one another, like fine layers of cosmic dust. A metal-rich body, an unnatural ratio of elements, a molecule familiar only to human industry. None of this proves intention, and yet each detail hums quietly with possibility. It's all right to not understand. In the silent cosmos, uncertainty is not a threat. It is an invitation, a reminder that the universe is vast enough to hold both the known and the yet unseen. 3I Atlas may be a natural wanderer shaped by environments that challenge our imagination, or it may be something crafted, something whose materials tell a story deeper than our histories measure. Either way, it asks us to listen, not to conclusions, but to questions. Let them drift across your mind like slowly falling dust. Let them settle without weight, without urgency. Tonight the stars will keep their silence. Sleep now, traveller. The cosmos remembers. When a solar storm leaves the surface of the sun, it carries with it a tide of charged particles, moving across space like a slow, luminous breath. Astronomers call these events coronal mass ejections, and they are among the most forceful natural expressions of our star. Whenever such a wave meets a comet, the result is almost always visible and unmistakable. A fragile object of ice and dust reacts with brightness, with turbulence, with a sudden stretching of its tail. These reactions are not dramatic in the human sense, but they are expected quiet consequences of physics unfolding as it has for billions of years. Yet when one of these solar storms reached 3i Atlas, the interstellar visitor drifting through our inner system, it produced something unexpected, nothing at all. The CME that struck Atlas in late October was not a gentle event. It was wide and energetic, its structure predicted days in advance by models that had been monitoring solar activity. According to the calculations of geophysicist Stefan Burns, the plasma wave should have reached Atlas around October 25th, just days before the object made its tight turn around the Sun. For any ordinary comet, this timing would have been perfect for an outburst. The coma would have brightened as charged particles excited the gases escaping from the surface. The tail would have stretched under the pressure of the solar wind. In previous encounters between comets and CMEs, astronomers have watched tails detach entirely a delicate strand of dust, torn away by the weight of the storm. But when the first post-storm data returned from Earth-based observatories, there was no sign that Atlas had been touched. Its brightness followed the smooth, predictable curve expected from ordinary warming, nothing more. Its coma remained compact and restrained. Its silhouette showed no turbulence, no sudden flare of activity, no evidence that it had interacted with the Sun's unleashed plasma at all. It passed through the storm with a stillness that felt almost deliberate, though nothing in nature is ever truly deliberate. It simply remained unchanged, as if made of something too solid or too stable to react. This quiet response challenges more than expectation. It forces a gentle reconsideration of what Atlas may be. Natural comets with their loose porous structures are easily perturbed. Their ices sublimate under heat, their dust scatters under pressure, and their tails respond visibly to the Sun's moods. If Atlas is not responding, perhaps it is because there is very little volatile material on its surface. A body rich in metal or carbon could slip through a CME without showing any visible change. A surface lacking large reservoirs of gas would not brighten under plasma. A dense core would not fracture. The absence of reaction may simply reflect the nature of the object itself. If this interpretation is true, it resolves one part of the puzzle while deepening another. A solid object of metal and carbon would explain the resilience, the muted reaction, and even the missing tail. But it also raises the question of how such a body formed and how it came to travel through interstellar space. The unusual nickel chemistry detected earlier adds weight to this question. Natural explanations remain possible, but each requires environments and processes that stretch the limits of what we've observed. In the quiet light of new data, astronomers hold space for all possibilities while anchoring themselves in observation. As the solar storm passed, two spacecraft, the Punch constellation near the Sun and the JUICE probe far from Earth, watched what they could. Punch recorded a compact source at perihelion, not dramatically different from the shape Atlas held before the encounter. JUICE, positioned at a different angle, gathered data that will not reach Earth until February, a delay dictated by distance and bandwidth. That waiting is part of the discipline of astronomy. Light must travel, signals must be received, instruments must speak in their own time, and so scientists wait not with urgency but with curiosity shaped by patience. The absence of change is not disappointing, it is instructive. In science, silence itself is a form of data. A comet that does not brighten tells us something. A coma that does not expand carries meaning. A solar storm that leaves no trace on an object that should have reacted offers a new piece of a larger puzzle, a puzzle that does not rush to be solved. There is a softness to this kind of mystery. It invites stillness rather than tension. The questions that arise are not alarming, they are humbling. Why does Atlas behave differently? What materials compose its core? Why does heat leave so little mark? These are not questions of threat or danger. They are questions of understanding of how the universe constructs itself, of how objects form in distant regions, of how matter responds to the forces that shape it. In this gentle uncertainty, there is room for reflection. The solar storm teaches us something about the Sun, but Atlas teaches us something about endurance. Not a heroic endurance, but a quiet one. The endurance of matter that persists without reaction, that carries its own history and its structure, that continues its path without announcing itself. This kind of endurance is rare among comets. It is not rare among objects that are more solid, more ancient or more carefully formed than we expect. As you sit with this, imagine the storm's journey, a wave of plasma sweeping across millions of kilometers, touching everything in its path. Imagine Atlas as it drifts through that wave unchanged, continuing on its trajectory with the same soft glow, the same muted coma, the same enigmatic presence. There is a serenity in that image, a reminder that not all interactions must be visible, not all forces must produce outward motion, and not all encounters leave marks that can be easily traced. What the solar storm did not produce may one day be as revealing as what it did. For now, the meaning rests quietly in the space between data points. It is enough to acknowledge the stillness and to let it guide the next questions. In the end, the calm response of 3i Atlas is simply one more whisper in a universe filled with them, a reminder that mystery does not always announce itself with brightness. Sometimes it moves silently, resilient and patient, waiting for us to notice the subtle ways in which it refuses to behave as expected. Tonight the stars keep their quiet distance, and somewhere Atlas continues its peaceful drift. There are moments in astronomy when the universe seems to fold neatly into our expectations, when light behaves predictably, when orbits obey the gentle mathematics that guide them. And then there are moments like this, moments when data drifts in, quietly carrying not answers but contradictions. For 3i Atlas, the contradiction is simple, elegant and deeply unsettling. The laws of physics insist on a tremendous loss of mass, yet no trace of that loss can be found. It is a paradox expressed not through drama but through absence, and absence in astronomy can be among the most eloquent forms of evidence. The calculations themselves are straightforward. When an object accelerates without the push of gravity, it must expel something. Momentum is conserved always and without exception. NASA's Jet Propulsion Laboratory measured this acceleration with high statistical confidence. A signal at 3.7 sigma is not noise. It is not wishful interpretation. It is a quiet but firm statement from the cosmos something pushed 3i Atlas. And if the push came from natural sublimation from ice turning into gas, then the amount of material expelled must be enormous, a 13% loss of total mass. Such a number does not hide itself in space. If Atlas had shed so much material, the evidence would linger for weeks or months. Light would scatter through the dust, gas would bloom outward and form a tail pushed by sunlight. This is the behaviour of comets near the sun, behaviour we have recorded for centuries. It is one of the few predictable rituals of the solar system, but the ritual was broken. The images taken after perihelion show a coma that is small, faint, almost unchanged from the observations months before. The missing mass is not there, the gas is not there, the dust is not there. The universe offers no plume, no arc, no gesture toward the expected. What remains is a shape so similar to its pre-perihelion form that the comparison borders on poetic symmetry. A before and after that refuses to differ. This is not a crisis for astronomy. It is an invitation, a reminder that nature is not obliged to satisfy our assumptions. When the data contradicts expectation, the proper response is not alarm but humility. We look again. We measure again. We ask what we have overlooked. We hold the paradox in our hands like a delicate object and examine its edges, its weight, its silence. There are always alternative explanations. Perhaps the gas was released but quickly dispersed into a cloud too faint for our instruments to see. Yet this seems unlikely when we recall that much smaller emissions from Atlas were detected in August, long before perihelion, long before its heating peaked. If we could observe that faint breath of carbon dioxide from a distant, quieter moment, how could billions of tons of material escape our detection now? Perhaps the gas was ejected in a direction that minimized reflectivity. But gas in the vacuum does not maintain alignment. It expands spherically until shaped by solar forces. Even the faintest plume would respond to sunlight and produce a visible structure. Perhaps the object is simply less icy than assumed, more solid, more metallic, more resistant. This would explain its resilience, its muted coma, its silence under solar pressure. But this too must be squared with the acceleration. If the body expelled little or no mass, what produced the force, measured in its motion? The gentle logic of physics remains unchanged. To be pushed, something must push back. This is where the questions deepen, not in urgency, but in quiet wonder. Scientists are often asked whether they believe one explanation or another, but science at its core is not built on belief. It is built on curiosity, on the willingness to sit with incomplete truths, on a reverence for the unknown. In the case of 3I Atlas, the unknown is layered chemistry that contradicts its category, a missing tail that contradicts its trajectory, and now a mass loss that contradicts its visible form. None of this demands extraordinary conclusions. It demands only patience. The universe speaks in slow sentences across vast distances through instruments that gather photons one by one. Every contradiction is a comma, not a period. Astronomers have begun to walk through the timeline of observations more carefully. From July to September, the object's motion was perfectly consistent with gravity alone. No acceleration, no deviation. It drifted like an untouched relic of interstellar motion. Then came October. As it neared the Sun, just when natural sublimation would be strongest, the acceleration appeared. Not gradually, but distinctly. A clean inflection point in its orbital behaviour. The timing is suspiciously perfect for the natural model. Perihelion heating should produce gas, and gas should produce acceleration. But the aftermath does not agree. If the cause fit the theory, the effect should be visible, yet only the cause is detected. The effect remains unseen, and so Atlas stands in the small quiet space between explanation and uncertainty. If heat caused the acceleration, where is the tail? If heat did not cause it, what did? The question is open, resting like a seed on the surface of a calm pond. This is the beauty of astronomy. The universe does not rush its answers. It allows room for hypotheses, for gentle speculation, for the controlled language of perhaps. Some scientists propose exotic chemistries. Others suggest unfamiliar structural compositions. A few consider the possibility of non-natural mechanisms, but even that is not a leap towards certainty, merely one path among many in a forest of unknowns. In the silent cosmos, doubt is not failure. Doubt is the beginning of listening. The absence of a tail after perihelion does not shout. It whispers. It suggests that 3I Atlas is not fragile, that it is not shedding mass freely, that it moves with a steadiness uncommon among comets. And steadiness in a universe shaped by heat and light is a property worth contemplating. As you sit with this mystery, allow it to settle gently. You do not need to reach a conclusion tonight. The universe is patient, and so must we be. Let the paradox drift through your thoughts like starlight softened by distance. Let the numbers breathe. Let the silence speak. It's all right to not understand. Tonight the data rests. So may you, traveller. The cosmos will keep watch. There is a quiet elegance in the way celestial bodies move. Their paths, shaped by the soft pull of gravity, create patterns as old as the universe itself. When astronomers trace these paths, they expect to see familiar arcs, trajectories that whisper of origins, distances, and the long histories of wandering objects. But every so often a path emerges that feels too precise, too neatly aligned, too improbable to ignore. In the case of 3I Atlas, its journey through the solar system carries a geometry that sits gently outside our expectations, inviting not alarm but contemplation. Atlas arrived on a retrograde orbit, moving opposite the planets, like a lone traveller walking upstream against the flow of a slow river. This alone is striking, though not impossible. But what followed was subtler and stranger. Its orbit aligned to within 5 degrees of the ecliptic plane, the thin disk upon which nearly every planet and asteroid makes its circuit around the Sun. For an interstellar object arriving from the vast unordered expanse between stars, such an alignment is rare. The odds are not zero, but they are quietly small, about 1 in 500. Yet probability in astronomy does not trouble itself with drama. Rare things happen, and they happen quietly. Still, the alignment was only the first whisper of something unusual. As scientists traced the rest of its trajectory, a pattern appeared. Atlas would pass remarkably close to multiple major planets: Mars, Venus, and Jupiter, each encounter offering an opportunity for observation. but each occurring at angles or times when Earth's view was obstructed. During its closest approach to the Sun, the object slipped behind the solar glare invisible to our best instruments. While it passed near Mars, NASA was in the midst of a government shutdown. Its imaging teams limited its communication channels quiet. While it crossed paths with Venus, our vantage point from Earth kept it hidden in daylight. One could dismiss these alignments as coincidence, yet the probabilities accumulate softly, like the layering of faint cosmic dust. 1 in 500 for the alignment. 1 in 20,000 for the planetary encounters. None of this proves intention, but it does encourage stillness, a patient re-examination of what it means for an object to move through our system in a way that feels curiously deliberate. Astronomers do not leap to conclusions. They fold these observations into a broader tapestry, comparing them with other interstellar visitors. The first, Oumuamua, followed a simple hyperbolic arc, fast tumbling and indifferent. The second Borisov behaved like a typical comet brightening into a beautiful tail. But Atlas sits between them, neither comet-like nor inert, neither chaotic nor simple. Its path seems structured, its motion gentle, its deviation subtle yet consistent. In quiet reflection, one scientist suggested that the so-called anti-tail, a sunward jet seen in Atlas during the summer months, might be interpreted as an artifact of geometry. Another noted that if the jet were real, it would run opposite the direction expected from natural sublimation. And if the jet weakened as the object neared the Sun, perhaps it hinted not at a natural flare of activity, but at something like a braking maneuver, a soft slowing, a controlled deceleration. This interpretation is not a conclusion. It is simply a possibility held gently without urgency. In the silent cosmos, hypotheses are not banners. They are lanterns that illuminate a segment of the dark without claiming to describe the whole. And yet the numbers remain. The odds, the curves, the timing. Each offers a small deviation from the expected. And when many small deviations gather in one place, even the most cautious astronomer must pause and breathe. None of this invites fear. It invites humility. The universe is old, far older than us. If objects pass through our solar system with patterns we do not quite recognize, it may simply mean our library of examples is still small. We have only seen 3 interstellar visitors. 3 is not a pattern, it is an introduction. We are students at the beginning of a long curriculum, and the cosmos is not obligated to teach us in familiar ways. So scientists return to what they know, best data geometry and light. They measure the orbit again, they recalculate the deviations, they model the pathways that random interstellar wanderers might take. And still, the numbers rest quietly, outside expectation, not dramatically, so, not alarmingly so, but just enough to create a soft tension between probability and reality. Astronomy is rich with such tensions. The history of science is shaped by their moments when something observed does not quite match something predicted, when an orbit bends slightly differently, when a spectrum carries an unexpected signature, when an object behaves with a kind of poise that does not fit the category we place it in. These tensions are not flaws, they are invitations. 3i Atlas offers such an invitation now. A path too aligned, a sequence too neat, a series of close encounters that seem less like coincidence and more like choreography. And yet, we do not know. That uncertainty, rather than diminishing the mystery, amplifies its quiet beauty. If Atlas followed a path shaped entirely by natural forces, then we must expand our understanding of how interstellar objects are guided through the galaxy. If its path involved forces we do not yet know how to name, then we must allow space for that possibility too. Whichever path is true, the humility required is the same. This is the heart of astronomy, a discipline shaped not by certainty, but by a willingness to let light teach us slowly. As the object continues its glide through the solar system, astronomers know more data will come. Observatories on Earth and in space will capture its motion from new angles. Models will improve. Probabilities will clarify. Some hypotheses will fall away. Others will sharpen. The geometry of its journey will eventually settle into a clearer narrative. But for now, the uncertainty is gentle. It asks only that we observe, that we listen, that we accept the simple truth that the universe often reveals itself in gradual, patient steps. You're not lost in space, traveller. You are part of its unfolding. And tonight the mystery of 3i Atlas rests quietly in its orbit, neither solved nor unsolved, but simply present, moving through sunlight, carrying its impossible alignment like a soft whisper in a vast listening cosmos. There is a moment in every scientific investigation when the evidence begins to gather at the edges of understanding, forming not a conclusion but a quiet pressure, like gravity shaping thought without forcing it. For 3i Atlas, that pressure arrives in the form of 10 small deviations, 10 soft departures from what we expect of natural objects. None of them alone is decisive, none of them shouts. But together they create a kind of cosmic hum, a resonance that invites the observer to sit a little longer with the unknown. Astronomer Avi Loeb once proposed a simple scale, 10 steps from the purely natural to the unmistakably artificial. Most objects in the sky rest easily at 0. A few unusual ones drift slightly upward. Oumuamua, the first interstellar visitor, reached the middle of the scale where certainty dissolves into possibility. And now, quietly, without fanfare, 3 Atlas finds itself at 4. Not exceptional, not conclusive, but enough to suggest that the familiar tools of classification may not fully capture what this object is trying to tell us. The beauty of the Loeb scale is not its drama, but its humility. It does not demand belief, it does not assign intention. It asks only that we measure how far an object strays from expectations. It allows uncertainty to remain a companion rather than an enemy. A 4 on this scale does not whisper technology. It whispers something gentler. Pay attention. The first anomaly is one of alignment. Atlas moves on a retrograde orbit that lies nearly flush with the ecliptic plane, the thin, fragile disk where the planets draw their paths around the Sun. For something arriving from interstellar space where directions are random and orientation is unbound, this alignment is improbable. It could be chance, of course. The universe is wide enough to accommodate the rare, but the alignment rests like the first note in a quiet progression. The second anomaly is the antitail observed during the summer months, a gentle plume pointing toward the Sun instead of away from it. Comets rarely do this. When they do, the effect is usually geometric, an illusion created by angle and perspective. But the antitail of Atlas lingered, behaved differently, and then faded as the object approached perihelion. To some, it resembled a physical jet. To others, a byproduct of viewing geometry. The truth remains suspended like dust caught in a beam of light. The third anomaly lies in its size. Atlas is vast compared to Oumuamua, 1,000,000 times more massive, and yet it moves faster than our previous interstellar visitors. If one imagines the population of interstellar wanderers as a distribution of sizes and speeds, the odds of meeting one this large this early in our observational history remain very small. Not impossible, just unexpectedly generous, as though the cosmos offered us a more majestic example sooner than statistics would suggest. Then comes the fourth anomaly, the choreography of planetary encounters. The object's path threads between Mars, Venus and Jupiter, with a quiet precision that feels almost like a survey route. Each encounter occurred at a moment when Earth's instruments were limited by geometry, timing or circumstance. Shadows and daylight, solar glare and bureaucratic silence each conspired to keep our view narrow. Again, this could be chance. But chance has a rhythm, and this rhythm feels a little too aligned with absence. The fifth anomaly is chemical, the nickel-rich iron poor composition discovered in its coma, a ratio that defies astrophysical norms, a molecule nickel tetracarbonyl that forms easily in industry, but demands exotic natural conditions. The spectrum whispers not certainty but curiosity. It asks where such chemistry might be born and whether we have yet imagined environments capable of creating it. The sixth anomaly is the unusual ratio of water to carbon dioxide. Most comets are children of water ice. Atlas seems to be a child of deeper cold, a relic born far from any star's warmth. But such cold cannot explain the nickel, and such heat required to forge metal cannot explain the abundance of carbon dioxide. Two origins echo in one body like two histories sharing the same memory. The seventh anomaly is the object's negative polarization. the way it scatters sunlight in a pattern no comet has shown before. Light in its purest form tells us about texture composition and the fine structure of dust. The polarization of Atlas suggests something unfamiliar, something unmodelled, something quietly new. The eighth anomaly is its colour shift near perihelion, a subtle brightening that drifted toward the blue. Natural objects often redden under sunlight as dust scatters longer wavelengths. Atlas moved toward shorter ones. The shift is small, gentle, but distinct, like a chord played slightly off key. The ninth anomaly is the acceleration itself, a push that gravity cannot account for, measured with statistical confidence and requiring mass loss that the universe has chosen not to show us. This is the soft heart of the paradox motion, without plume force, without evidence momentum, without trace. And then the 10th, perhaps the quietest of all, the missing tail. The absence that should not be. A comet that has lost 13% of its mass should not look calm, compact, unchanged. It should be adorned with the long, luminous veil that marks every comet near the sun. Instead, Atlas moves with a stillness more characteristic of something solid, something resilient, something unwilling to be reshaped by heat. 10 anomalies, 10 small deviations, none definitive, all gently persistent, gently. And together they carry a weight that is not heavy but contemplative. Astronomy has seen such clusters before, not often, but enough to remember that science is not built on eliminating mystery, but on welcoming it. When the unexpected arrives, the proper response is not to force it into old patterns, but to listen for what new patterns may be forming. For 3i Atlas, the emerging picture is not alarming. It is beautifully uncertain. A relic from elsewhere carrying chemistry we do not yet understand. A traveller whose path brushes planets in quiet sequence. A body that accelerates without shedding. A comet-like form without comet-like behaviour. This is not a contradiction to fear. It is a contradiction that invites humility. And so, as the observer settles deeper into night, the lesson becomes clear: the universe is not obligated to match our expectations. It is older than our theories, broader than our models, and more patient than our attempts to explain it. Some mysteries are not meant to be solved quickly. Some are meant to be witnessed. Some are meant to rest quietly on the scale between known and unknown. Tonight the stars keep their gentle vigil. Sleep now, traveller. The cosmos remembers. There is a rhythm to the universe that reveals itself only to those willing to wait. Stars form over millions of years. Galaxies drift through one another in slow tides of starlight. And when a visitor from another star enters our solar system, the truth of its nature does not arrive all at once. It unfolds through whispering data, through faint spectra, through quiet deviations in motion. With 3i Atlas, this unfolding has led to a moment of deep anticipation. December 19th, the day when the object will pass closest to Earth, and when our finest instruments will finally measure its secrets with the sensitivity they require. Astronomers are not waiting for spectacle, they are waiting for clarity. For months they have lived with a contradiction. The acceleration that demands mass loss, and the sky that shows no evidence of it. December offers not certainty, but the possibility of resolution. As the object drifts toward its closest approach, telescopes across the world are preparing for a coordinated moment of listening. The James Webb Space Telescope, with its unparalleled ability to read faint molecular signatures, will point its golden mirror toward the interstellar traveller. Hubble, older but still sharp, will do the same. Ground-based observatories will join, each gathering their portion of the story in wavelengths invisible to our eyes. Yet even as these instruments prepare, a quiet truth hangs in the air. The universe may offer an answer that is neither comfortable nor complete. It may tell us only part of what we wish to know. The central test is simple, elegant and unforgiving. If the acceleration of 3i Atlas was caused by natural sublimation by ice boiling into gas, then the object must be surrounded by billions of tons of recently released material. And if that material exists, Webb will detect it. The faintest cloud of carbon dioxide or water vapour will reveal itself as a signature in the spectrum, as a gentle pattern of absorption and emission written into the light. If, however, the gas is not there, if the coma remains thin, unchanged, and insufficient, The natural comet hypothesis will not merely weaken, it will fracture. The universe does not permit acceleration without cause. If sublimation cannot explain the motion, the explanation must come from elsewhere. This is the crossroads we now approach, not a fork between belief and disbelief, but between two scientific pathways. One familiar, one unknown. December does not promise certainty, it promises direction. Scientists imagine the moment when Webb's first spectrum arrives on the screen, a sequence of peaks and valleys, each corresponding to a molecule drifting near the interstellar object. In control rooms, far from one another, researchers may sit silently watching. The data assemble pixel by pixel. They may breathe more slowly than usual. They may hold still. The universe rarely delivers a moment this pure, and yet even then the result may not be binary. It may not be the clear yes or no that so many imagine. The coma could hold some gas, but not enough. The signature could be faint, ambiguous, shaped by processes we do not yet model. In that ambiguity, a new sort of mystery could emerge, a grey region, where natural and unnatural explanations touch, blur, and overlap. This possibility is not a frustration. It is a reminder that the universe rarely bends itself to our categories. There is also a deeper question, one that hums beneath all others. What if the object is not made to be understood through the behaviour of a typical comet at all? What if it is something more solid, more patient, more enduring? Something that carries its own internal logic, one that remains indifferent to our models of ice and dust. These questions are not dramatic. They are gentle. They recognise the humility required when confronting something older than our species, older than our instruments, older than our sky charts. As December approaches, the astronomical community finds itself moving in a rare harmony. Observatories that normally compete for telescope time now share a common purpose. Scientists who debate fiercely in journals now speak with a unified curiosity. Even those who reject the more exotic implications of Atlas acknowledge the unusual nature of the data, the need to observe deeply, precisely, and without assumption. Meanwhile, the object itself drifts with perfect indifference. It does not accelerate for our benefit. It does not reveal its composition because we are watching. It continues along its path, guided by forces we partially understand and partially guess. It does not ask to be interpreted. It simply is. There is a quiet beauty in this. The cosmos does not offer meaning as humans do. Its stories are not moral. Its mysteries are not designed to provoke emotion. Yet we find meaning in the act of observing. We find emotion in the patience that astronomy demands. And in the space between prediction and reality, we discover humility. Consider, traveller, the timescales at work. The light Webb will capture in December will have left Atlas mere minutes before, but the materials it measures may be billions of years old. The object itself may have wandered the galaxy since before the Earth cooled, before continents formed, before life emerged. The moment of observation is brief. The journey it records is ancient. As you reflect on this, imagine the stillness of deep space surrounding the object. Imagine the solar wind flowing past it like a soft tide. Imagine the dust grains drifting gently in its wake, few in number, faint in light, yet carrying the memory of their origin. The December observations may answer the central question, or they may only deepen it. But either outcome enriches us. Knowledge grows in two directions, through certainty and through the recognition of uncertainty. Both are forms of progress. Both are forms of wonder. In the end, the approach to December feels less like a climax and more like a meditation. A reminder that some truths unfold slowly. A reminder that the cosmos reveals itself not in declarations but in whispers. Tonight the stars hold their silence as they always have. Sleep gently, observer. The universe is still speaking, and soon its next sentence will arrive in the light of a distant traveller. As 3i Atlas moves steadily along its path toward the outer reaches of our planetary neighbourhood, a deeper question begins to rise softly, tentatively, the way dawn spreads across a quiet horizon. What happens if we are wrong? Not wrong in the sense of error or miscalculation, but wrong in the assumptions we carry beneath our models. Astronomy is as much about humility as it is about discovery, and moments like this invite a gentle revisiting of what we believe, why we believe it, and how ready we are to see the universe without the filters of familiarity. Scientists have begun to frame the uncertainty surrounding Atlas in two simple possibilities, two quiet branches of possibility that extend outward like the arms of a spiral galaxy. On one branch lies the natural explanation, the idea that Atlas is merely an unusual comet, shaped by environments that challenge our understanding but do not contradict nature. On the other branch lies the uncomfortable, astonishing alternative that the acceleration, the chemistry, the silence after perihelion may not come from natural processes at all. To most researchers, the first branch is more comfortable. It rests within the well-lit pathways of astrophysical tradition. But the second branch, though unsettling, carries its own profound elegance. It suggests that perhaps we are witnessing the work of something older than us, something crafted by minds we do not yet understand. Not an announcement, not a signal, just a quiet visitor drifting through the sun's light. The consequences of each path differ not in scale, but in meaning. If Atlas is natural, the story becomes one of discovery, a chance to refine our models, expand our understanding of interstellar chemistry, and approach future objects with greater sensitivity. If Atlas is artificial, the story becomes a new chapter in our place within the cosmos, not dramatic, not frightening, simply expansive. And yet the third possibility, the one humans rarely embrace, is that the answer may remain ambiguous. The universe often resists the clean borders we prefer. It offers gradients, not binaries. Atlas may present a blend of natural and unfamiliar properties. It may hold signatures that hint toward intention without revealing it. It may remain a visitor whose story we cannot fully decipher, at least not yet. There is a quiet strength in accepting such ambiguity. Certainty is comforting, but wonder grows more easily in the space where answers are incomplete. As the scientific debate unfolds, the question of risk emerges in a gentle, philosophical way. What is lost if we treat Atlas as natural when it is not? And what is lost if we treat it as possibly artificial when it is simply unusual? The first loss is irreversible. If an interstellar artifact passes through our solar system, and we fail to recognize it, the opportunity will not return. It will continue into the dark, carrying its secrets into a space too distant for us to follow. For a young species still learning the basics of interstellar observation, this would be a missed moment, a whisper of first contact carried away on a silent trajectory. The second loss, however, is softer. If we suspect technological origins and later discover a natural explanation, we lose nothing but an idea. We gain knowledge, refine our models, and move forward. The mistake becomes a lesson, not a failure. In this calculus, curiosity outweighs caution, not as a reckless gesture, but as a reasonable embrace of possibility. Astronomy has always been shaped by such asymmetries. The great turning points in science have come not from certainty, but from the willingness to consider the improbable. When Galileo suggested that Earth moved around the Sun, the idea was unthinkable to many. When Wegener proposed the drifting of continents, his peers dismissed him. When humanity first accepted that rocks could fall from the sky, meteorites, the idea reshaped our view of the heavens. None of these transitions came quickly. They came gradually, with hesitation, with resistance, with a slow widening of the collective imagination. And so we return to Atlas. Not as a herald, not as a threat, but as a test of our readiness to expand the boundaries of what we consider possible. Consider, traveller, the quiet future that awaits us after December's observations. Whether the gas cloud exists or not, whether the tail appears or not, the universe will not rush an answer. More interstellar objects will come, our instruments will sharpen, our ability to study visitors from other suns will grow. The silence we hear now may one day be filled with signals we do not yet know how to detect. If Atlas is natural, we remain students in a galaxy filled with lessons. If Atlas is artificial, we become witnesses to a story that began far before our species existed. Either way, the cosmos remains generous. There is a perspective within the scientific community, a quiet, steady one that suggests we are at the beginning of a new era, the era of interstellar archaeology, of studying relics from beyond our star. In this view, Atlas is not an anomaly. It is a messenger of what is to come. A first chapter in a long book we're only beginning to open, and if in some distant future humanity were to sail between stars, we too might send objects like the small, patient travellers meant to observe to wander to survive long after their makers have changed or vanished. In that reflection, Atlas becomes not a stranger but a mirror. It's all right to not understand. Let this uncertainty settle around you like the soft hum of the night sky. Let the possibilities drift through your thoughts without weight. Do not force them into answers. Allow them to remain questions luminous and open the way distant galaxies glow with light that has not yet reached us. Tonight the universe offers not a conclusion, but an invitation to wonder, to listen, to accept the mystery without fear. Sleep now, observer. The cosmos keeps its patient watch. And somewhere far beyond our reach, Three-Eye Atlas continues on its silent path through the dark, unhurried, unchanged, and still holding its story gently within itself. There is a kind of stillness that settles over observatories in the weeks before a major astronomical event, a stillness made not of emptiness, but of anticipation. As December 19th approaches, the world's telescopes seem to lean inward like listeners gathering around a whisper. Each instrument from Earth's deserts to the cold vantage points of space prepares to catch the faintest breath of light from Three-Eye Atlas. This is the moment astronomers have been moving toward for months, the moment when questions become measurements, and when speculation softens into data. The object does not hurry. It drifts in its long, silent arc, indifferent to the attention it receives. Yet for us small observers on a small world, its approach represents something vast, almost solemn. Not because it promises revelation, but because it invites us to listen more deeply than we ever have before. The nature of this moment is shaped by a single elegant test. Whether the coma of Three-Eye Atlas contains the mass that physics demands must be there. If the object accelerated through natural sublimation, through the warm breath of its own evaporating ices, then its surroundings should now be filled with billions of tons of gas and dust. Not metaphorically, not hypothetically, in a literal measurable way. A tail should stretch behind it, luminous or faint but undeniable. A cloud should wrap its surface expanding outward like a silent halo. Yet nothing we have observed so far suggests such mass exists, and so December the 19th becomes more than a date. It becomes a threshold between competing truths, one familiar, one strange. It is a place where the universe allows us to test not only our models, but our humility. The James Webb Space Telescope, with mirrors shaped like golden petals, will search for spectral lines that betray the presence of carbon dioxide, water vapor, carbon monoxide, the familiar molecules of cometary breath. Webb is sensitive enough to detect far less material than the physics of acceleration demands. If the coma is present, it will see it. If it is missing, the absence will be unmistakable. Hubble, orbiting high above Earth's atmosphere, will observe Atlas in visible light, searching for the faint scattering of dust that even the most stubborn comet cannot fully hide. Ground-based spectrographs using adaptive optics to pierce through atmospheric turbulence will scan the object's glow for chemical fingerprints. Together these instruments form a kind of cosmic chorus, each adding its own quiet notes to the melody of inquiry. But the truth, traveller, is that none of these observations can guarantee a complete answer. The universe does not always reveal itself with clarity. Sometimes it offers ambiguity as a kind of test, a reminder that understanding is a journey rather than an arrival. The coma might exist, but in reduced form, enough to explain part of the acceleration, but not all of it. The spectrum might show unusual ratios that do not match any known models. The dust might be sparse, uneven, or shaped by forces we have not yet imagined. If the answer is ambiguous, it will not be a failure. It will be an invitation to continue. Astronomy thrives in uncertainty. Uncertainty is the dark sky in which curiosity brightens. Yet ambiguity is not the only possibility. The universe may choose to speak plainly. If Webb reveals a massive coma, if billions of tons of material surround the object, then the mystery softens. The natural comet model survives, unchanged in its broad strokes. We will refine our assumptions about the rate of sublimation, about the timing of outgassing, about the alignment of the coma with our line of sight. But the foundation remains. Atlas becomes a remarkable comet, but still a comet shaped by ice and sunlight. If, however, the coma is faint if the mass is not there, then the questions grow deeper. This does not point to alien technology. It points to the limits of our understanding. It forces us to confront the possibility that forces or materials unknown to us may be at work. It expands our sense of what natural objects might be, and it opens the door gently and quietly to interpretations we have long considered improbable. But before those interpretations can be explored, the data must speak. And so, we wait not with tension but with reverence. Astronomy teaches patience not as a burden, but as a posture, a way of listening. The photons that will land on Webb's detectors on December 19th have travelled only minutes from Atlas itself, but the story they carry may have been shaped over millions of years. The object we observe may have drifted through dead star systems, through nebulae lit by the ashes of supernovas, through magnetic fields older than our world. What we measure on that day is not simply a transient cloud of gas. It is the accumulated history of an object whose origins lie far beyond our solar cradle. There is something profoundly human in this attempt to understand a visitor we cannot touch. We build instruments of glass and gold, we place them on mountaintops or release them into orbit, and we ask them to catch whispers from the dark. We craft algorithms that translate photons into meaning. We form communities that debate, question, refine. And at the centre of it all is a simple desire to know where we are and with whom we share this vast, quiet universe. In the days leading to December, conversations among scientists take on a softer tone. The debates remain sharp, but beneath them lies a shared recognition of the moment's importance. Not because they expect contact or confirmation or revelation, but because they are participating in a rare opportunity, the chance to see the universe behave in a way that challenges their assumptions. Such moments are not crises, they are gifts. And you observer listening beneath the quiet roof of night are part of that moment. The wonder you feel gentle, drifting contemplative mirrors the wonder of astronomers whose lives unfold in the thin air of observatory domes. The universe does not belong to them. It belongs to all who look up and ask questions. As December nears, the nights may feel longer, the stars steadier, the air quieter. This is not imagination. It is the mind preparing itself for the unknown's softening opening, becoming more attuned to the subtleties of cosmic time. When the data arrives, it may resolve the paradox, or it may deepen it. But either way, the universe will have spoken, and we will have listened. Some mysteries are not meant to be solved instantly. Some are meant to be approached slowly, patiently, like distant lights in the fog of space. Tonight the stars wait with you. Sleep gently, traveller. The cosmos will keep watch. There is a delicate tension in the days before knowledge arrives, a tension not of fear but of expectancy, like the hush before dawn or the quiet breath before a telescope shutter opens. As the observation window approaches, humanity finds itself in an unusual position, waiting for an answer that could shift our understanding of the cosmos, yet knowing that the universe does not hurry for us. December 19th moves closer, neither fast nor slow, simply carried forward by celestial mechanics older than our species. And in this gentle drift toward revelation, we find ourselves reflecting not only on Three-Eye Atlas, but on the nature of discovery itself. In academic offices and observatory halls, conversations grow softer. These are not the heated debates of competing theories, but the thoughtful murmurs of scientists acknowledging the magnitude of the moment. They have run the models, checked the orbits, debated the chemistry. They have exhausted the familiar explanations. Now they wait for photons, for spectra, for the truth written in wavelengths invisible to human sight. They wait not for drama, but for clarity. Yet even clarity may not come in the form we hope. The universe has a quiet habit of offering answers that deepen the mysteries they resolve. It gives us data, yes, but seldom gives us closure. In these final days before the close approach, an almost philosophical mood settles over the community. Scientists remind themselves that whichever outcome emerges, it will enrich our understanding. If the coma is present in the mass required, then we will refine our comet models. If it is absent, then we will expand our definition of what natural objects can be. If the evidence leans towards something unfamiliar, something engineered rather than formed, then we will confront an idea humanity has long entertained in fiction, but never in observation that intelligence may not be unique to Earth and that other minds may shape objects that travel between the stars. It is this third possibility that hovers quietly, not stated, but felt like a low harmonic beneath the louder notes of analysis. Scientists are cautious with such thoughts. They tread lightly, knowing that the history of astronomy is filled with moments when extraordinary interpretations preceded ordinary explanations. But they also recognise that progress in science requires openness, not to speculation, but to the idea that nature may be stranger than our theories allow. As this tension hums beneath the surface of scientific discourse, a deeper reflection emerges, the realization that the universe is under no obligation to reveal itself cleanly. Human minds crave dichotomies, yes or no, natural or artificial, comet or craft, but the cosmos prefers gradients, transitions, ambiguities that stretch our imagination and challenge our assumptions. Atlas embodies this ambiguity. It is neither fully comet-like nor wholly asteroidal. It accelerates but does not shed the mass demanded by sublimation. It glides through solar storms without reaction. Its chemistry whispers of extremes, deep, cold, fierce heat, industrial volatility, yet arranges these whispers into a pattern we cannot quite decipher. It is a visitor that defies the categories we've built for natural things, but does not yet step into the realm of the engineered. There is beauty in this in-between state, a beauty shaped by possibility. Possibility, after all, is what keeps science alive. And yet, as we ponder Atlas, a more intimate thought rises. What would it mean if the universe were truly inhabited, not by civilizations that seek us, or by beings who announce themselves, but by wanderers, relics, silent artifacts drifting between the stars? What would it mean if the cosmos were already whispering to us through such objects, not with intent, but by presence? Some astronomers imagine a scenario in which ancient civilizations scatter probes through the galaxy, not unlike seeds carried on a cosmic wind. These probes could outlive their makers, sailing silently for millions of years. They could enter young planetary systems the way seeds land on fertile soil, observing drifting, waiting. If so, Atlas might be one among many, not the first, not the last, simply the first we have noticed. This is only one interpretation, not a conclusion. It is offered not as truth, but as reflection. In the silent cosmos, ideas are not declarations. They are meditative explorations of what might be. But the possibility invites a deeper humility. If three-eye Atlas is natural, then we must broaden our imagination about how nature creates objects in environments we have not yet observed. If it is artificial, then we must broaden our imagination about who else shares the galaxy with us and why they move through it so quietly. In both cases, the universe expands. As December approaches, the human response becomes introspective. We look outward at the object, but also inward at ourselves. What does it say about humanity that we search for meaning in a drifting traveller? What does it say about our readiness to accept a universe richer than we imagined? What does it say about our hope, that ancient persistent hope, that we are part of something larger, something ongoing, something that began long before us and will continue long after? These thoughts are not scientific, yet they arise naturally from science. Knowledge and meaning have always intertwined. A spectrum becomes a story. A trajectory becomes a question. A missing tail becomes a metaphor for the ways in which truth can remain hidden, even when all the calculations insist it should be visible. In the days leading toward the observations, one sentence seems to echo through the astronomical community, spoken quietly, almost reverently. We are on the edge of knowing, and that is a sacred place to be. It is sacred because it reminds us of our limits. It is sacred because it invites humility. It is sacred because it opens a door to wonder. And so, traveller, as you rest beneath your own sky, you share that edge with every scientist waiting for light from Atlas to reach their detectors. You share the uncertainty. You share the hope. You share the simple human longing to understand the universe that made us. No matter the result, something profound is unfolding. Humanity is learning how to listen more deeply. Not for signals, not for messages, but for patterns, for the subtle ways the universe reveals itself in silence. And perhaps that is the greater story here, not whether Atlas is natural or artificial, but what its presence awakens in us. A readiness to see, a willingness to doubt, a courage to wonder. The cosmos teaches gently. December brings its next lesson. Tonight, sleep in that knowing, soft, unhurried, open to the vastness. The universe keeps its vigil, and Atlas continues its quiet arc through the dark. And so, traveller, we drift to the quiet edge of this journey together. From the first unexpected images after perihelion to the unanswered questions they left behind, we have followed Three-Eye Atlas like a faint lantern moving through the dark. Each detail, each anomaly, each whisper from distant instruments has led us here to this still moment beneath a sky older than memory. Whatever Atlas may be, a natural wanderer shaped by ancient ice or a crafted relic crossing the void with purpose. The truth tonight is softer than certainty. It is simply this: the universe remains awake, alive, and endlessly speaking in ways we are only beginning to understand. You and I, observer, are part of that conversation. By watching, by wondering, by letting mystery exist without demanding resolution, we participate in the oldest dialogue in the cosmos, the dialogue between light and the mind that perceives it. Perhaps the most meaningful discovery is not whether Atlas is comet or construct, but how deeply its presence reminds us that curiosity is a kind of courage, and that awe is a form of quiet wisdom. Tonight, let yourself rest in that feeling, in the knowledge that you are small, yes, but never insignificant. Every question you carry, every uncertainty, every moment you choose to look up instead of turning away. These are the threads that connect us to the wider universe. Three-Eye Atlas will continue on its path silent and unhurried. The telescopes will continue watching, and somewhere beyond the reach of our instruments the cosmos will keep its steady breath. For now, close your eyes, traveller. The night is vast but kind. Stay curious and sleep well beneath the stars.